Okay, I do this a lot. I shoot a video, realize that a lot of what I say is a waste of time. So I'll try and give you the quick summary. I got two Echo 590 620 cylinders. That one's brand new 620 cylinder. It's got 35 thousandths off the base. That one's a used 590 cylinder. It's also got 35 thousandths off the base. Both of them got enough out of the chamber to set the squish to 20 thousandths, which typically you do a base gasket delete. They sit around 25 to 30. So we got 10 more past that. And let's see, yeah, we got 10 more past that. So it's somewhere between 10 and 15 out of the chamber on these. They're both getting ported. This will kind of let you show. I'm doing similar numbers on both of them. I mean, there's probably a degree difference. There's the gap. That's how much I move a 620 exhaust. It's not a whole lot. There's how much I move 590 exhaust. Much bigger gap. There's 590 transfers. There's 620 transfers. This is why people say a 620 is basically a ported 590. All your port sizes and angles are the same. The only difference is port durations. Your chamber size is the same. Chamber volume is the same. So again, your there's nothing gain. There's no difference in chamber size. You're just changing durations. That's pretty much what porting is. These, I did change the chamber a little bit. I give them a real small band. I think it helps. If nothing else, it keeps the outer edge of the piston a little bit cooler. That's part of what a squish band does. Can I say for a fact it does that? No. Have I read in books written by smarter people than me that it does that? Yes. So that's one chunk of the video. The next chunk would be this cylinder I set at 104, 124. That is what the last one I did was, and it ran very well. So I'm going to try to replicate the last one. This one, I picked my exhaust height to set my compression ratio. That's what all these goofy numbers are. I measured my chamber volume, measured the exhaust height to figure out what I can squeeze out of there, still maintain a compression ratio higher than factory. If you can create a compression ratio higher than factory and run a duration a little bit more radical, then you're pretty much guaranteed to pick up power. I say pretty much because I'm sure there's some situation out there where that does not apply. On this one, it definitely does. So that's your factory height, at least with the chamber work. 29.26 millimeters. I'm going to move it to 25.4, and it just so happened that it also sets it to 103.5, the same numbers that I had picked on that one. I just did some math on paper, and that's what I decided. Hey, this is what I'm going to run, and it turned out to be the same as what that one was. That's my dryer going off. So this is the 5-minute rundown of the video. There's my notes if you want to look at it. That's a stock 590 compression ratio. That's a stock 620 compression ratio. This is the one that the ported saw will have. 7.4 to 1. 6.3 is my chamber volume, including squish. That's for this little math problem there. So we're looking at that. Anyway, I don't walk you through it very well, but I just kind of ramble about it in the saws. A 4910 is also going to be a build upcoming. If you're wondering, at 20,000 squish, chamber on a 4910 is roughly 4 cc's. That's reasonably small. I thought it was way more than that, but you know, the measurements, I'm not going to lie to you unless you did it wrong. And I've done this enough times now that I don't think that I fudged up that bad. So enjoy the rest of the video or peace out here. It's up to y'all. If y'all got any questions about this, leave them in the comments. Alright, got a fresh 620 cylinder here that's already laid out. Widths are kind of close. I check them a lot on the 620 because I don't want the ring drop in on that side. Or no, it's that side that it'll drop in on. But check them a lot. I think this one's laid out at 104, 124. The last one I did that ran with a stock 390, stock 394, it was the same number, so I'm just trying to replicate that. It ran really well, so that's what I'm after here. This is a 590 cylinder. It's gonna be a little bit different. I hadn't put a wheel on it yet. Man, I thought, no, this isn't the one that I marked out. That was a 4910 cylinder that I marked out this morning. Hang on, I'll mark this one because I got an idea where I want to go with it. Okay, here's the 590 cylinder, and that's what I'm going with. It gives you 25.4 millimeters of of stroke length above the exhaust. It sets you up for a 7.4 to 1 compression ratio. If stock on a 590 is 7.2, stock on a 620 is 6.9. That's your corrected compression ratio. Really, your downfall on this cylinder is going to be that massive chamber that it's got and the lack of being able to do more substantial machine work. For every 20 thousandths or so, you gain a 0.8 cc's. So you gain almost a cc of you take away a cc of volume out of the chamber for about every 20 thousandths you can take. 20 thousandths is roughly all you can knock out of there. There's a ring of death. You might be able to see it in that light where the plating don't run all the way to the top, but the crown on the piston is, where to set my piston? Right here. Crown on your piston is pretty tall, so you have a little bit of room to work with. I mean, not the distance from the ring to the crown of the piston. I don't remember what this is called, but yeah, you have a little room to work with is all I'm getting at, but not a lot of room to work with. That's going to use up 67% of your total stroke length. Just as a reference, on a 4910 at, what was it? Eight and 3/4 to 1 compression, you're using up 63%. So you're already well above your compression ratio on the 620 with less stroke, chamber smaller. So really all I want to touch on, that one I'm just using a degree wheel and past experience. This one I'm trying to apply some science to and pick a compression ratio, go with it. We're higher than factory, but we should be at a pretty similar duration here. I'll see what it actually turns out to be. But the little bit we took out of the chamber should help. And then, you can run similar durations. Your whole difference here is the 590 has a much lower exhaust roof, and then they're using corrected compression ratios. The 620 is going to register a higher cylinder pressure on a compression test, though, because you have a second ring. The second ring in the piston traps oil. It just makes it seal that much better. Does it add power? I don't think so. I think while the engine is operating, your combustion pressure or peak cylinder pressure is probably similar or greater on the 590. I don't think the little bit of seal at low RPMs, i.e. a compression test, is going to drastically change your peak cylinder pressures, which that's where I think your power is going to come from. Peak cylinder pressure over your corrected stroke distance. The harder you can push it down, the harder it's going to pull, essentially. Now, everything that helps you on the way down fights you on the way back up. So there is a balance aspect of it there. The race saw I ran was like 9.2 to 1 compression. I think 9 to 1 compression ratio is probably too high. But that's why I'm making these notes, is to find out what too much compression is. You can't really go by your compression gauge on a compression test, because that's just measuring cylinder pressure. And you can cheat a compression test. Spray a little bit of penetrating oil in there and then start pulling on the rope. Your measurement is going to be way higher than if it was a cold cylinder, a cold engine that sat overnight. And then transfer design and crankcase compression is going to play into that as well, because since you do have a crankcase, since there is crankcase compression, you are compressing a charge past atmospheric levels, at least in theory. I hadn't measured it yet to see if it actually produces a pressure. I think I have an idea on that to find out, but I haven't played around and followed through with it. So I don't think anymore that the compression gauge is necessarily a good tool for performance, as an indication of performance. So that's why I am switching to corrected compression ratio. It's not that hard to CC these chambers. I mean, all you do is smear grease on a piston run it up to the top. You have a ring on the piston, smear a little grease around it, run it up to the top, back it out, whatever your squish measurement is, and then trickle water in through your spark plug hole. And I just measure it at the threads. I figure if you measure it at the threads every time, whatever the spark plug takes up volume wise, it's going to be the same. So you should have at least a repeatable result that way, and something to base numbers off of. I was going to try for 8-to-1 compression on here, but you just can't. Your durations are going to be at like freaking 110 on the exhaust or something. I don't know that would make good power anywhere on a 60cc saw, and it was using, that would make it use like 76% of the total stroke of the exhaust. Here it's 67. The 4910 I'm going to do 63. I don't think the stroke percentage is anything crucial. It's just anecdotal evidence for now. If you find out like, hey, everything that I run is at 64% is freaking screaming, then maybe it's worth pursuing. But I don't think it's worth pursuing now, but I am keeping track of it. I think the corrected compression ratio is the better one to keep track of. So there's my rambling. I'm going to set it up and see exactly where this falls, and that's probably the end of the video. And with the exhaust height that I picked, 1 inch, 24.5 millimeters, sit at 103.5. So, like I said, that one and the last one I did was 104. I was pretty close just by trial and error. It's like, hey, I think that's where they run pretty well at. Once you start dropping, to a larger duration than that, I think you lose. I think you're losing a significant amount of compression because they just don't have that great of a compression ratio to begin with. So that's fairly interesting. I didn't think that I'd be that close just from trial and error, but there might be something to doing it by numbers. So at that point, so from here, I already know a few things. The 620, I believe, has like a 105, 106 exhaust, and I think the 590 is like 109 or 110. I'm already half a point higher on compression ratio with a greater duration. If in the general sense of things, if you have more compression with a greater duration, you're setting up for more power or more power potential. So should come out on top of that pretty well. Even at the same numbers, if I dropped it back lower, I'd be closer to, I think, 7. I'd be closer to 7.5, 7.6 or so, and it have the same running characteristics. It just have a lot more beans behind it. That's kind of your torquey feel. that everyone calls it torque, but it's just power. Torque is just a measurement. It's just a unit of measurement, and you really can't. I'm getting tired and jumbling up my words, but it's difficult to quantify from the way something feels, because you could have something that pulls really well at high RPM and your torque value is going to be lower than something that doesn't pull that hard. Just because it's a unit of measurement, it's not. It's only one part of the equation for power. It's not everything there is. But yeah, there's the end of the video and plan for things. This is kind of a new route. I think it's promising. I don't know for sure. Only one way to find out, and that's to try.